If it wants me to match a linear relation to its graph, then typically that means I'm just going to take all the equations and I'm going to put them into my slope intercept form. So in the first one, it is in general form right now. So what I'm going to do is I'm going to move the x and the constant over. Negative y is equal to negative 2x minus 3, and then divide by the coefficient of y. Y is equal to positive 2x plus 3. And there's my equation 1. Equation 2 is already in the right form, so I don't need to change anything with that one. And that one's good to go. For equation 3, I can either choose to put this in a slope-intercept form, or I can use the slope point form that it's given as. I'm going to use it as a slope point form that it's given as because I can show how to do that as well. And for the last one, I'm going to do the same process. I'm going to put it into slope intercept form. So I'm going to start by isolating the y. 2y is equal to x plus 6, divide everything by 2, y is equal to 1 over 2x plus 3, and there's my equation 4. Now I can figure out what all of them are based on the graphs. So if I am trying to find the one that is equation 1, what I'm looking for is I'm looking for a y-intercept of 3 with a slope of 2 over 1. Well, this one has a y-intercept of 3, which means that if I can go up 2 and write 1 to get to another point, it would work, but that one does not match. This one has a y-intercept of 3, and I should be able to go up 2, write 1. That one also does not work. We can see through the process of elimination that the only one that has a point of 3 and goes up 2 and right 1 is going to be graph D. We can call that equation 1. For equation 2, I need a y-intercept of 3 and a slope of negative 2, which would be going down 2 and right 1. So I check graph A. It's got a y-intercept of 3. I go down 2 and right 1, get to another point on the graph. Well, that was easy. This is equation 2. For equation 3, I want a graph that has a slope of negative 1 over 2 and goes through the points. Well, if this is 1 and this is 4, it goes through the point of negative 4 and negative 1. So I'm going to look through here. This does not go through negative 4, negative 1. This one does go through negative 4 and negative 1, not positive 1. Negative 4, negative 1, negative 4, negative 1, negative 4, negative 1. And we can see that the only graph that actually goes through that point is going to be graph C. It says it has a slope of negative 1 over 2, go down 1, right 2, and this one works. This one is equation 3. By the process of elimination, I would guess that equation 4 should be B. This one says that it has a slope of 1 over 2 and a y-intercept of 3. I'll have my y-intercept of 3 here, and I go up 1, right 2, goes through another point. This one is going to be equation 4. If I am graphing linear equations with technology, then the first thing I'm going to do is I know that I can only graph these in the form of y equals. In my calculator, it comes up as a y equals. So all I'm going to do is I need to isolate y and make sure that y does not have a coefficient. So for the first equation, in order to get y by itself, I just need to move the 8 to the other side. I don't need to put it in slope point or slope intercept or whatever it happens to be. I just need to get y by itself. I can say y is equal to negative 5 x minus 2 minus 8, and then just graph that into my calculator. I don't have to do anything more complex than that. If I want to, so that I can check it and verify it and see if it's going to work, if I want to, I can put this into slope point form, or slope intercept form as well. I could say y is equal to negative 5x plus 10 minus 8, or y is equal to negative 5 plus 2. The benefit to putting it into this form before I graph it is then I can know basically what it looks like. I'm going to have a y-intercept at 2, and I'm going to have a slope of negative 5 over 1, which should help me figuring out what this looks like. In the second case, I'm going to do the same thing. I got to isolate y, so I'm going to say negative y is equal to negative 4x minus 9, and then divide by the negative because y has to be positive for this to work. 4x plus 9. Y is by itself, and conveniently enough, it is in slope-intercept form, so I should know basically what this looks like. It's going to have a y-intercept at 9 and a slope of 4 over 1. If I want to state window settings that will work for these, well, a window setting that's going to work for both of these is I'm going to state that the x is going to have a minimum of negative 5, a maximum of 5, and a scale of 1. And for y, I'm going to say that I'm going to put in with a minimum of negative 5, a maximum of 15, and a scale of 2. Then when I actually go to graph it, I should wind up with something that looks relatively like this. I'm going to have my first equation, and this one is going to be the, that's my second equation. And this one is going to be the 4x minus y plus 9 is equal to 0, where I can see that I have that y-intercept at 9 and a positive slope of 4. And my other equation is going to look something like this. Where I have that slope of negative 5 over 1, I have that y-intercept is going to be at 2, and I can call this one y plus 8 is equal to negative 5 bracket x minus 2. If I am determining the x and the y intercepts, in this case, then all I would have to do is, well, the y-intercept, I can just hit trace 0 and enter, and it's going to tell me that in this case it has a y-intercept of 9. If I want to solve the x-intercept, I'm going to put in a second equation, y is equal to 0, and then I'm going to solve for the intersect points. So depending on whether you're using a Casio or using one of the other ones, you can go second, trace, and then do the calculate for intersects, or you can just use the intersect function on the calculator, which I believe is Casio, which is, I believe, F4. And if you're doing that, then you're going to see that the x-intercept is going to equal negative 2.25 or 9 over 4 as a fraction.